For the spell work, I would just use, I'd make this a proportion and solve it with fish method. So, something like this. Just divide these two. Of course, they're equal because they are similar triangles, and then use some fish method right there. There's our objective. I can find different values in volume. When we're talking about different values from volume, and we'll explain more about this later, but looking specifically at height, radius, sometimes diameter, sometimes volume as well, okay? But based on the formulas that we're going to be seeing, we should be able to do that. All right, today we're looking specifically at volume of circular type shapes. Three-dimensional, of course, because we're looking at volume. Now, just going back a little bit, it's important to remember that with circles, just a little bit of vocabulary on this, okay? Now, before, when we talked about circles, we looked at circumference, which would have been the distance around the circle, the edge of the circle. It's pretty much the perimeter of the circle. And yeah, well, we've seen this stuff before, just a little quick reminder. It's right in the center of that circle, and yes, we get to pretend like I nailed the center of that circle. Well, that actually is the center of the circle, that point right there, okay? It's called the center. We don't use this vocabulary, the center, very often, but it's important for you to know these other two words in today's lesson. So, for example, if you start from a point on the edge of the circle, it could be anywhere on the circle, by the way, and you drew a line straight through the center to the other side, and again, we're still pretending like I drew a straight line right here. That is called the diameter. And yeah, that should not be new for us at this point. On the other hand, the diameter goes all the way through from one edge of the circle through the center to the other side. If you just went from the edge of the circle to the center, of course, that's half the diameter. That's what we call radius. So this shows us, hopefully visually, assuming my drawing's halfway good enough, that the radius is half the diameter, or that the diameter is double the radius, either way. But these are the two main words we're going to be looking at. Now, I think I've said this before. Of course, there's other parts of circles that can be drawn and defined, but we don't really care about those right now, okay? All right, first up, a cylinder, and we have seen cylinders before. So notice that the cylinder has a circular base and top, of course. And then we saw if we were to actually stretch this out into a net, this would be a rectangle right here. Now that's for surface area though. Today we're looking at volume of the cylinder. And the formula for the volume, I know it shows it right there, but I like to draw it with colors because it's pretty. So I got pi times the radius to the power of 2 times the height like this. And there's something you should notice in this formula is that you got pi times the radius to the power of 2. And yes, when we went over this with the area of circles, this was radius times radius. But this is the area of a circle. So what you're really doing is find the area of the circle and then multiplying it by the height. That will give you the actual volume of the cylinder, okay? But the formula for the area of a circle is built into the volume formula for cylinders right there. Pi times the radius to the power of 2. Now, what they're going to be doing today, especially since last time we talked about roots, is sometimes they're going to give us volume and height, and they'll say, hey, find the radius. Whenever we find the radius, it will involve roots of some type. In this case, of course, square roots, because the exponent is 2. Other times they'll give us the radius and the volume, and then they'll say find the height. And we've got to be able to solve those as well. But we're just using principles of equality to solve those, all right? And yes, from time to time, they'll ask for the diameter as well. On this one, we're going to find the volume of this cylinder. Now, you could draw a picture of the cylinder, but you guys have seen my drawing, so I'm going to avoid it. And what do we see on this one? Let's look at the formula first. Volume, this is a cylinder. Volume should equal pi times the radius to the power of 2, but then multiply that by the height. And what values did they give us on this one? The diameter first. Well, the diameter is not part of the formula directly, but the radius is. So I know that if I want the radius, I can take the diameter, which is in this case is 8.8, and I just need to divide it by 2. That will give me my radius at 4.4, that'd be centimeters. So since I know the radius, I can replace it into the formula. By the way, I think this goes back to, what was it, unit 3 or 4, where we're just evaluating formulas like this. Well, the radius I just replaced with the value we know it is, 4.4. And then the height was also given here at 9 centimeters, so I replaced the height with 9. I'm using parentheses to show the multiplication. You don't have to. You could, though. But this is a direct calculation, which means I can just plug it into the calculator right now. And you'll notice, if you look at the second button in the top left, 3 buttons down from there is an actual pi button. That is what I'm using to calculate these. Some of you may prefer to use 3.14, but I'm a lazy math guy, so it's too much work for me. All right, so pi times 4.4, and I push that x to the power of 2 button, just one to the left of 7, and it gives me the squared, the power of 2, and then I multiply that by 9, and this says 547.391104. I'm going to round this to the nearest tenth, which would be 547.39, means that's going to be 4. Of course, that's in centimeters. That's centimeters cubed, by the way. Or, of course, you could, if you wanted to, write it as 547.4 cubic centimeters, and that would be fine too. Along those lines, though, if you wanted to use, like if you did this by hand by chance, and I think that's a slim chance, but you'd have to do the exponent first, right? 4.4 to the power of 2, then multiply by pi, then multiply by 9. But you'd get the same answer. You should get the same answer. The volume of a cylinder is 117.1 cubic feet, and the height is 15 feet. Find the diameter of the base of the cylinder. It's just a circle. How do we know it's a circle? Because it's diameter. Well, let's look at the formula for the volume of a cylinder, which is pi times the radius to the power of 2 multiplied by the height. And yeah, see this one, they gave us the volume on this one. That's okay, which is 117. So I'm going to replace my V for volume with 117.1. And the other value they gave us here is the height at 15 feet. So I replaced my height with 15 feet. So you notice in the formula here again that we're solving for radius. Okay, that's all right. They did ask for diameter though, which means we're going to have to perform one final calculation after we find the radius. All right. So on this one, I'd say I'm going to do this in 2 steps, and later on I'm going to show you how to do this in 1 step though. All right. This next 2 steps. So right here, remember when solving equations, we have to use principles of equality, right? So whatever you do to one side, you got to do the other side. And right now we're just trying to isolate my r to the power of 2, which means I do not want the pi or the 15 there. So how do I get rid of it? Just divide it by itself to make it a phantom 1. But again, see how I divided pi right there? If I do it to that side, I also must do it to this side as well. Okay. So in my calculator, yeah, I'll need more space. I'm going to put 117.1 divided by, again, I'm using the pi button. And that gives me, looks like 37.27, so I'll just make that 37.3. I think I typed that in right. And this will equal what was left of the right side of the equation, r to the power of 2 times 15. But now, I got that times by 15 right there. I don't want that there either, so I'm going to make it a phantom 1 by dividing both sides by 15, making that a phantom 1. So now I got r to the power of 2 equals whatever this is, 37.3 divided by 15. Enter. I get 2.486 and some change. Looks like 6 repeating, but I'm just going to make that 2.5, round to the nearest tenth. Okay? Need a little bit more space here, of course. That brings up the next step here, because we do just need r, not r to the power of 2, because we're looking for the radius. And so, well, we're looking for the diameter overall, but right now we need the radius to find the diameter. So since that's a power of 2, I'm going to square root both of these, which would then give me just the radius. So on my calculator, I got 2.5. I'm going to square root that. Remember that second x to the power of 2 button? And then I put 2.5, enter, and I get 1.58 and some change. Of course, I'm going to just round that to 1.6. Okay, so that'd be 1.6 feet. But we want the diameter. So the diameter is the same as taking the radius, 1.6, and I just need to multiply that by 2. That will be my diameter. So let's see, 1.6 times 2, 3.2. Of course, that's feet right there, right? There's my diameter. That's a good point. If you wanted to go back and just check to make sure this works, you know, you have pi, you know you're 15, just replace your radius with 1.6. It may not be exact, by the way, because we did a lot of rounding in there, but it should be at least, I would say, within a tenth of what we have right there, maybe 2/10. Volume of a cylinder, 4,224.8 cubic millimeters, has a diameter of 16.4 millimeters. Find the height of the cylinder. Okay. So again, while I did the division in 2 steps, I'm going to show it in 1 step in this case. All right. But let's look at the volume of a cylinder. The volume equals pi times the radius to the power of 2 times the height. And yeah, this one we're solving for the height. But they didn't give us the radius, did they? Well, they kind of did indirectly. It's just in a diameter format. So if I want the radius, I'm going to take my diameter, 16.4, and I'll have to divide it by 2, which means my radius is 8.2 millimeters. So I can go in and replace my radius with 8.2. I skipped the volume. I should have done that first. Doesn't matter, because it's not going to change. The volume here is shown 4,224.8 cubic millimeters. Now, in solving here for the height, I have a radius to the power of 2, pretty much by the order of operations. I'm going to evaluate that. Now, do I have to? No, not necessarily. But I'm going to because I want to. So, let's go ahead and just evaluate that. 8.2 to the power of 2. Again, that's just in the calculator right there. 8.2 power of 2. I get 67.24. Now, I know we're rounding to the nearest 10th, but that's not a hard decimal to show. And that's exact, by the way. So then this changes the equation just a little bit. I'd say it's even simplified just a little bit. 4,224.8 equals pi times 67.24 times the height. And so see how that evaluated the exponent to get 67.24, all right? Now, like I said, I'm going to do this division in 1 step because I can, and I like it, probably more than I should. But I'm going to divide both sides, not only by pi here, right, to make that a phantom 1, but I can simultaneously divide by 67.24. Now, in the denominator it's shown as pi times 67.24. That's okay, especially with the calculators that we have, because I'm going to use the N over D button. Now, 67.24 divided by itself is 1 right there. That leaves me with just the H, right? It's just left over. But I need to evaluate that 4,224.8 over pi times 67.24 in the denominator specifically. So since I have it set up like a fraction, I'm using the N over D button. And in the denominator, I'm showing pi times 67.24. When I push enter, I got a syntax error because I typed it in wrong. But I got 19.999993467. If I rounded that to the nearest 10th, hopefully that's not too hard, but it's 20. 20 millimeters. And as it turns out, that's the answer we wanted, is the height of that cylinder. Before we go to volume of cones. Yeah, so let's start with volume of cones here. Now again, the unique thing about cones is they got this circular base right here. It's just, you can see if there is a relationship between cones and cylinders, which we're going to talk about here in a second. But you see that pretty much a cone is carved out from a cylinder right here. It's just, well, how much of the cylinder is the cone? Well, that's where our formula comes in play. See, this is the volume formula for a cylinder. And you may notice that it has the same exact formula in the cone volume formula. It's just now it's divided by 3. Now, there's one way to show it, and I forget why it was shown this way, but it's legitimate. I just show it a little bit different, okay? So when I show volume for cones like this, again, we're going to keep the same formula for the cylinder, pi times the radius to the power of 2 times the height. But I would then show it as all over 3 like this. So I use the N over D button. You can use 1/3 if you'd like, and then just use multiplication straight across. It's not going to matter. You'll end up with the same answers either way, all right? So what this means, that divide by 3 there indicates that a cone, if you looked at a correspondingly related cylinder, it's 1/3 of that cylinder. So like if you were to fill this cone 3 times and then pour whatever was in the cone into the cylinder, you could fill this 3 times, and then once you poured it in there, then this would be full as well. Yeah, we're going to find the volume of the cones or whatever value that they ask us to find. A cone with a radius of 8.4 feet and a height of 5.5 feet. This is direct because we are solving for the volume. And the volume formula for a cone, pi times the radius to the power of 2 times the height, all over 3. And yes, here is our radius, 8.4 feet. So I replaced my radius with, well, 8.4. And it says the height is 5.5, so replace the height with 5.5. Well, again, this is a direct calculation right here, so I'm just going to plug this directly into the calculator. So I'm using n over d, not that you have to, but whichever way you do it, you should end up with the same answer. In my numerator, I got pi times 8.4 to the power of 2 times 5.5. I go to my denominator, and that's just 3. Enter, and I got 406.396427. I'm just rounding to the nearest tenth, though, so 406.39 would make that tenth place value of 4. And this is volume, so it's in feet cubed. Okay, remember the 3 there is indicating that it's 3-dimensional, which volume is. Or of course, you could have put cubic feet if you'd like, and it's the same thing. A cone with a diameter of 9 meters and a height of 4.2 meters. Okay, well, no problem. Still a volume formula for cones specifically. Pi times the radius to the power of 2 times the height, all over 3. Okay, well, on this one, they did not give us the radius. They gave us the diameter. No problem. We can find the radius simply by taking the diameter, 9, and dividing it by 2. Now, I'm going to use the decimal for this. You could use the fraction because it has the same value, but that shows the radius here, 4.5. So I replace my r with 4.5. And the height is 4.2 meters, so I replace h for height with 4.2. So the volume here is going to equal, well, let's put this in the calculator again. So for me, n over d, pi times 4.5 to the power of 2 times 4.2, all over 3. And I get, in my calculator, 89.06. So I'm going to make that 89.1. Again, that's cubic meters in this one. So here they give us the volume of a cone and its height. We need to find the diameter of the base. Well, let's look at the formula with volume of a cone. Volume of a cone is pi times the radius to the power of 2 times the height. And that's the cylinder formula for volume, but we're dividing it by 3 because the volume of a cone is a third of the volume of a cylinder. Well, here's the volume, 122.8. So I'm going to replace my volume with 122.8. And here's the height at 4.5 inches. So my h for height becomes 4.5. Now be careful too, because from time to time, you just never know. Math jerks sometimes will be like, hey, this one's in cubic inches and this one's in feet. Just know that that can happen from time to time, although I do not believe it happens on the assignment. Yeah, so like on this one here, to solve it, right, first thing I would do is get rid of that divide by 3 garbage. So I'd say, look, I'm going to multiply this side by 3 to make that a phantom 1. It's just the principle of equality says if you do it to one side, you got to do the other side as well. So what am I left with on the right side? Well, still got your numerator, pi times the radius to the power of 2 times 4.5. But what does this equal? Well, now we actually have to do this multiplication. 3 times 122.8. I get 368.4. So now at this point, well, I think I did those in 2 steps in the first problem. But the second one here, now that we're past that, I'm going to do this in 1 step. Okay, so I'm going to do this division in 1 step. So I'm dividing by pi times 4.5 to make these phantom 1s. And yeah, even these are separated. Remember, it's just multiplication throughout, so we can divide these like this, okay? But if I do it to one side, I must do it to the other side as well. And so, This is going to equal r to the power of 2. I know we're not actually finding the radius, but we need it to find the diameter. And now I can put that 368.4 all over pi times 4.5. And again, I'm using the n over d button here. Pi times 4.5 in my denominator. I get 26.05. I'm just going to round that. We'll make it 26.1. Now that's radius to the power of 2. I just want the radius. Since it's a power of 2, we're just looking at square root here. So now my radius, let's put this in, square root. So that's second x to the power of 2, 26.1. Enter. I get 5.1. So that's inches, by the way. But we don't want the radius. We do to find the answer, but what we really want is the diameter. So to find the diameter, I take the radius, 5.1, and I multiply it by 2. So this would give me my actual diameter, which is what we want. D for diameter, 5.1 times 2, 10.2. Don't forget to label this as well. It's in inches, of course. So the volume of a cone is 188.5 cubic feet, and it has a diameter of 12 feet. Find the height of the cylinder. That's supposed to say cone right there. Spelling's hard. Cone. Okay, because we're on the cone part of this. So, again, let's look at the volume formula for a cone here. So, volume equals pi times the radius to the power of 2 times the height all over 3. And what do they give us on this one? Here's our volume at 188.5. I'm going to need a little bit more space here. Let's get rid of that V, though, and change it for its value, 188.5. And then they gave us, oh, here's the diameter. That's good. So, but I want the radius. So to find the radius, just take your diameter, which in this case is 12, divided by 2, which would then be 6. So the radius of the cone is 6. And yeah, we are finding the height of this thing. So the first thing I'm going to do, although you do not have to do this at this point, you can do it later if you'd like. But for me, I'm going to perform 6 to the power of 2. Right? So that's 6 times 6. So it's not going to simplify the formula too much, but it does just a tiny bit, I guess. So in my numerator, I now have pi times 6 times 6, which is 36, times the height. And again, like I said, you didn't have to do that at that exact moment that I did, but you can. Now I want to get rid of that divide by 3. How do I do that? Well, make it a phantom 1 by multiplying it by 3. It's just if you do it to one side, you got to do the other side as well. So that's a phantom 1 now, which makes this pi times 36 times the height. And this equals, let's see, 3 times 188.5, enter, 565.5 when I multiply these. Okay, well, by the way, I should have mentioned this before, but this value that we just found right here, this would be the volume of a cylinder that has the same measurements, right? But we want this, the height of this cone. So, next up, yeah, again, one step. Divide these both by pi times 36 to make these phantom 1s. And that will give us the height, which is what we want. All right, so I'm going to put this in the calculator, n over d, the fraction button, 565.5. I go down to my denominator, pi times 36, enter, and I get 5.00011 and some change. That's just rounding to 5. So that'd be a height of 5 feet. So spheres are great because they're circular. Now, spheres also have the circle, the area of a circle formula in it. It's just, it's kind of hidden a little bit. There it is. Volume for a sphere, 4/3 pi times the radius to the power of 3. Now the volume formula, you can see even on the poster, is written like this, but I prefer to write it more like this especially when we're calculating for other values. So the volume is going to be 4 times pi times the radius, but now the radius is to the power of 3. And this is all over 3. You'll notice the difference between this formula and the previous ones for cylinders and cones, hopefully, is that this formula has only two variables, either volume or radius. So if they say, well, find the volume, they either have to give us radius or diameter, or if they want us to solve for the radius, they have to give us volume. There's no height in this because, well, the height of that sphere is the diameter of the circle, okay? So they got to give us one of these two, but they really only got to give us one of those two pieces of information, then we solve for the other one. And yeah, well, the circle formula's in here. It's just, now it's those two r's that are multiplied are in this r to the power of 3. So let's find the volume of a sphere with the radius of 1.3. No problem. Volume of a sphere, 4 times pi times radius to the power of 3, all over 3. And yeah, you could ask, well, I almost put pi right there, that's a radius. You could say, well, how do you get this formula? Well, there's lots of different ways to do it. I don't know of a really good way to explain it now without making it super confusing. So if you want to find that, I go to YouTube and say, how do you get the volume formula for a sphere? And then watch those videos, but I assume you'd be asleep by the time it's over. So on this one, well, they gave us the radius at 1.3 right there. So I'm going to replace my radius, r, with 1.3. All right? And yeah, this is a direct calculation because it's solving for volume here. By direct, it means I can put that directly into the calculator. So in the calculator, again, n over d, 4 times pi times 1.3. Now I need the power of the exponent button, right? Which is it's just right above the x to the power of 2 button. So that's 1 to the left of 7, 1 up. It's just right below the pi button, by the way. So I got to push that button. Exponent button 3. Now I got to get out of exponent function of the calculator. So I got to either push over or down. So I'm going to push over, and then I push down to go to the denominator. I put a 3, enter. I get 9.2027, so just 9.2. In this case, yards, but yards cubed. And again, you could put cubic yards if you'd like. It's not really going to change anything there, but there's our volume. Let's find the volume of a sphere with diameter 25 inches. Oh, this is diameter. So let's find the radius because we know the formula for a sphere. Volume is equal to 4 times pi, times the radius to the power of 3, all over 3. Now this one, of course, gives us the diameter, but we just want the radius. So to do that, we're going to take the diameter at 25 inches and just divide it by 2. And again, you can keep the fraction if you'd like, but I'm going to take the decimal on this one, 12.5. And I'll replace my radius with 12.5. There we go. To the power of 3, right? And again, this is a direct calculation, which is why we're doing this. 4 times pi, n over d, 4 times pi times 12.5 to the power of 3. Then get out of exponent mode, and then divide by 3. 3 in the denominator. That gives me 8,181.23, which means I'm going to just make it 2. This time I'll put cubic inches on this one. There it is. Now this one is asking for diameter, not radius, but we're going to have to find the radius anyways because it's in the formula, right? So what is the formula for the volume of a sphere? Volume of the sphere is 4 pi, times the radius to the power of 3, all over 3. And in finding the radius, we'll be able to find the diameter correspondingly with this. But yeah, they gave us the volume here, so I'm going to replace my volume with the value they gave us, which is, 6,882.3. Now I need a little space there, so I'm going to move it. And why do I need some space? Because I want to get rid of that divide by 3. Now, could you get rid of the 4 pi right now? You could. Could you get rid of the cube? No, you could not. Well, you could, but it would make things worse. So I'm going to say, look, I'm going to multiply both sides by 3 to make that a phantom 1. Divide by 3, which means I just want it to be phantom, right? Which leaves us with 4 times pi times radius to the power of 3. This equals, let's go ahead and multiply those. 3 times 6,882.3 equals 20,646.9. Okay, again, I'm going to do this in one step, the division here. I'm going to make the 4 and pi phantom ones. To do that, I'm going to divide both by themselves, 4 and pi. But if I do it to one side, I must do it to the other side. So there's 1, there's a phantom 1. So I am left with radius to the power of 3. See if I can fit this in here. And we're going to take that 20,646 and divide it by 4 times pi, right? And I get, try to use the right color here, 1,643 point, I got 0.2, so I'm just going to make that 0.0.
Isn't it 16,000?
All right, be careful with that, because if you, let's show what was typed in the calculator here, okay? So 20,646.9, and then the calculator shows divided by 4 pi like this. Remember the order of operations? The calculator thinks you want to divide the 20,646.9 by 4, and then you take that and multiply it by pi, which would have given you whatever it was, like 16,000 or something like that, okay? If you're gonna type it in with a division symbol like that, you need parentheses around the 4 pi. Now it knows you want to divide by 4 times pi. And then it would give you that 16,043.0 whatever it was, like I got right there. So on this one, now that we got that, hopefully that clarified that with plugging it into the calculator. Yeah, r to the power of 3, we just want the radius. Now since it's an exponent of 3 for the radius, we need a cube root in order to make that a phantom 1 exponent, right? But if I do it to one side, it is required that I do it to the other side. So this is going to give me just the radius, which is really what we want to find the diameter. Now I need to type this into the calculator though, right? So I push 3-second exponent button, and you'll see the cube root now. And this is 1643.0. I push enter, and I get 11.79 and some change, which means that I'm just going to round this to 11.8. And of course, that'd be in inches. 11.8 inches, but we don't want the radius. We want the diameter. But the diameter is the radius, 11.8. You just got to multiply it by 2. And this will give us the actual diameter. Let's go and multiply these by 2. 11.8 times 2 in my calculator, 23.6. And this one's just inches. It's just one dimensional because it's diameter. It's one length. So that's our answer right there. So here's our objective. I can find different values in volume. Again, today we saw as radius, diameter, height, and volume of these circular shapes, right?